Article 312.8 of the National Electrical Code addresses the number of wires permitted in a grounding terminal. It states that the number of wires permitted in a grounding terminal shall not exceed the number of screws provided, and the total cross-sectional area of all the wires shall not exceed the cross-sectional area of the terminal. This requirement aims to ensure a secure and effective ground connection. It is important to note that exceeding either the number of screws or the cross-sectional area can compromise the integrity of the grounding system. The grounding system is a crucial safety component within an electrical installation. Its purpose is to provide a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. A properly functioning grounding system minimizes the risk of electrical shock hazards and equipment damage during fault conditions. When terminating grounding conductors in a Loadcenter, it is essential to carefully examine the terminal block and identify the number of screws available. Each grounding conductor should be securely fastened under a separate screw to ensure a reliable connection. Avoid stacking multiple grounding conductors under a single screw unless the terminal is specifically designed and listed for such applications. In addition to the number of screws, the cross-sectional area of the grounding conductors must also be considered. The total cross-sectional area of all grounding conductors terminated in a single terminal should not exceed the cross-sectional area of the terminal itself. This limitation prevents overcrowding and ensures that the terminal can effectively conduct fault currents. To determine the cross-sectional area of a grounding conductor, refer to the wire size and ampacity tables provided in the National Electrical Code. These tables list the cross-sectional area for various wire gauges. Calculate the total cross-sectional area of all grounding conductors to be terminated and verify that it does not exceed the terminal's capacity. Article 312.10 of the National Electrical Code covers the number of wires permitted in a neutral terminal. Similar to the requirements for grounding terminals, Article 312.10 states that the number of wires permitted in a neutral terminal shall not exceed the number of screws provided, and the total cross-sectional area of all the wires shall not exceed the cross-sectional area of the terminal. Neutral conductors carry the unbalanced current in an electrical system and provide a return path for current flow. Maintaining proper neutral connections is crucial for ensuring system stability and preventing voltage imbalances. Overcrowding or improperly terminating neutral conductors can lead to overheating, voltage fluctuations, and equipment malfunction. When terminating neutral conductors in a Loadcenter, it is important to adhere to the same guidelines as for grounding conductors. Each neutral conductor should be securely fastened under a separate screw, and the total cross-sectional area of all neutral conductors terminated in a single terminal should not exceed the terminal's capacity. Pay close attention to the terminal block configuration and identify the number of screws available for neutral connections. Avoid stacking multiple neutral conductors under a single screw unless the terminal is specifically designed and listed for such applications. The National Electrical Code provides detailed requirements for grounding and bonding in electrical systems. Grounding refers to connecting electrical circuits and equipment to earth, while bonding involves connecting metallic parts of an electrical system to create a continuous electrical path. Proper grounding and bonding are essential for minimizing the risk of electrical shock hazards and ensuring the safe operation of electrical equipment. The size of grounding and bonding conductors is determined based on the size of the overcurrent protective device protecting the circuit. The National Electrical Code provides tables that specify the minimum size of grounding and bonding conductors for various circuit sizes. It is crucial to select the appropriate conductor size to ensure adequate fault current carrying capacity. Grounding electrodes are used to connect the electrical system to earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The National Electrical Code specifies the requirements for grounding electrode systems, including the number, size, and installation of grounding electrodes. Bonding jumpers are used to connect metallic parts of an electrical system to create a continuous electrical path. Bonding jumpers are typically installed around knockouts, conduit fittings, and other metallic enclosures. The National Electrical Code specifies the requirements for bonding jumpers, including the size and installation methods. In addition to the requirements outlined in Article 312.8 and Article 312.10, other sections of the National Electrical Code also address grounding and neutral connections in load centers. Article 408 covers switchboards and pallboards, including requirements for grounding and bonding. Article 250 provides comprehensive requirements for grounding and bonding in electrical systems. When working with electrical systems, it is essential to follow all applicable codes and standards. The National Electrical Code is the primary standard for electrical installations in the United States, and it provides detailed requirements for safe and reliable electrical systems. Always consult the latest edition of the National Electrical Code and any local amendments to ensure compliance. Proper grounding and neutral connections are critical for electrical safety and system performance. Adhering to the requirements outlined in Article 312.8 and Article 312.10 of the National Electrical Code, as well as other applicable codes and standards, helps minimize the risk of electrical shock hazards and equipment damage. It is important to carefully examine the terminal block configuration, identify the number of screws available, and ensure that the total cross-sectional area of all conductors terminated in a single terminal does not exceed the terminal's capacity. Remember to consult the National Electrical Code for detailed requirements and guidance on grounding and neutral connections. In addition to the number of wires allowed, the physical installation of the wires at the terminals is important. Wires must be properly stripped to the correct length to ensure good contact with the terminal. Too much insulation left on the wire can prevent proper contact, while too little insulation can expose bare wire, creating a potential hazard. The terminals themselves must be in good condition. Over time, terminals can corrode or become damaged, which can affect their ability to make a good electrical connection. Damaged or corroded terminals should be replaced. When tightening the screws on the terminals, use the proper torque. Under-tightening the screws can lead to loose connections, while over-tightening can damage the terminal. Use a torque screwdriver or a wrench to ensure that the screws are tightened to the manufacturer's specifications. After the wires have been terminated, inspect the connections to ensure that they are secure. Gently tug on each wire to make sure that it is firmly held in place by the terminal. If any wires are loose, retighten the screws. Proper labeling of the wires is also important. Labeling makes it easier to identify the wires in the future, which can be helpful for troubleshooting or making modifications to the electrical system. Use wire markers or labels to clearly identify each wire. It is always best practice to take a photograph of the wiring inside the load center before and after making any changes. This provides a visual record of the wiring configuration, which can be helpful for future reference. Always to energize the circuit before working on any electrical equipment. Turn off the circuit breaker or remove the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is de-energized before touching any wires or terminals. If you are not comfortable working on electrical equipment, it is best to hire a qualified electrician. Electricity can be dangerous, and it is important to take precautions to protect yourself from electrical shock. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or installations. In addition to the NEC articles mentioned, the equipment listing and labeling play a significant role. Load centers are typically listed by Underwriters Laboratories or another recognized testing laboratory. This listing indicates that the equipment has been tested and meets certain safety standards. The listing also specifies the types and sizes of conductors that can be used with the load center. Always use conductors that are listed for use with the equipment. The labeling on the load center provides important information about the equipment, including the maximum voltage and current ratings, the number of circuits, and the type of overcurrent protection devices that can be used. It is important to read and understand the labeling before working on the equipment. Some load centers are designed for use with specific types of conductors, such as copper or aluminum. Other load centers can be used with either type of conductor. The labeling will indicate the types of conductors that can be used. When using aluminum conductors, it is important to use the proper connectors and termination techniques. Aluminum conductors expand and contract more than copper conductors, which can lead to loose connections over time. Use connectors that are specifically designed for use with aluminum conductors, and follow the manufacturer's instructions for installation. Antioxidant compound is typically required when terminating aluminum conductors to prevent corrosion. The compound helps to create a good electrical connection and prevent the formation of aluminum oxide, which is a poor conductor of electricity. The National Electrical Code also addresses the use of multi-wire branch circuits. A multi-wire branch circuit is a circuit that consists of two or more ungrounded conductors that have a voltage between them, and a grounded conductor that has equal voltage between it and each ungrounded conductor of the circuit and that is connected to the neutral or grounded conductor of the system. When using multi-wire branch circuits, it is important to ensure that the grounded conductor is properly sized to carry the maximum unbalanced load. The National Electrical Code provides guidelines for sizing the grounded conductor in multi-wire branch circuits. Another important consideration is the use of surge protection devices. Surge protection devices protect electrical equipment from voltage surges, which can be caused by lightning strikes or other electrical disturbances. Surge protection devices are typically installed at the service entrance of the building or at the load center. The National Electrical Code provides requirements for the installation of surge protection devices. Always follow the manufacturer's instructions when installing surge protection devices. Regular inspections and maintenance of electrical equipment are essential for ensuring its safe and reliable operation. Load centers should be inspected periodically for signs of damage, corrosion, or loose connections. Any problems should be corrected promptly. It is also important to keep the load center clean and free of debris. Dust and dirt can accumulate inside the load center, which can lead to overheating and other problems.